Hello, welcome to Jamaica Virtual Learning. We welcome all new viewers to our channel and we would like to ask you to subscribe and share with your friends and like this video. Thank you very much. In today's lesson, we'll be talking about reflection of shapes. We're going to have 4 different lessons under transformation. And in transformation, we have 4 major topics: reflection, translation, rotation, and enlargement. So we begin our first one on reflection. So by the end of the lesson, I hope that you will be able to reflect shapes in given mirror lines, and you will also be able to describe reflection of shapes properly using the right keywords. Before we start, can you spend a couple of minutes to see if you can get the equation of all these 6 lines? Okay, let's check the answers. Line A is called y equals 2. Line B is called x equals -3. Line C is y equals x. Line D, y equals -x. Line E is y equals 0. And line F is x equals 0. These are names of equations that you must be familiar with because most of reflection questions in the exam make use of these kind of lines. So the rule of thumb here is all horizontal lines are named after y and all vertical lines are named after x. That's why this line goes through 2 on the y-axis, so we call it y equals 2. This line also is x-axis, but it goes through 0. That's why it's called y equals 0. Vertical lines are named after x. That's why this one is called x equals -3, because it cuts the number -3 on the x-axis. And the y-axis is called x equals 0 because it also goes through point 0. Okay, so I'm going to give you different examples of reflection. Let's look at example 1, horizontal reflection. Here we have a triangle and we need to reflect in a line y equals -1, and we label the new triangle B. Right? You hear me use the words object and image. Object will be the original shape and image will be the reflected shape. So when you hear me say object, I mean the original shape and the image will be the reflected shape. So in reflecting this object, we first need to know where our mirror line is. Y equals -1. Now, you need to remember that when we say reflection, it simply means a flipping of shape. So in doing reflection, each corner or vertex of the triangle is going to be flipped perpendicularly over the mirror line. That's the rule of reflection. You flip each side or each point perpendicularly over the mirror line. So let's identify our mirror line. Y equals -1. That is the line. So we're going to flip the corners or the vertices of the triangle perpendicularly over to the other side of the mirror line. So all you need to do is to take a point, see how far you are from the mirror line, and do the same distance on the opposite. That's what reflection is all about. So let's see. This point is 3 squares away, so it's going to be 3 squares down. Next point, also 3 squares away, 3 squares down. The last point, 5 squares away, 5 squares down. Then at the end, all you need to do is to join the end of those lines, and that will give you your object. Sorry, the image. So we now have an image which is triangle B. And the rule is we just flip each point perpendicularly over the mirror line. They move in 90 degrees. So B is the reflected image and the green triangle is the original triangle. So this one is called horizontal reflection, flipping over a horizontal line. Let's look at the second example. Here we're going to do 2 reflection. First is to reflect triangle A in the x-axis, and we call it triangle B. Then we do from triangle B, reflect in the line x equals 1 and call it triangle C. So let's do it in step. First is to reflect A in the x-axis and call it triangle B. Remember, we'll flip it in a perpendicular manner. So first is the x-axis as a mirror line. So that's our mirror line. We check the first point, 1 square away, 1 square on the other side. Next one. And the last point. At the end, join the end of the lines. So that's my B. Now I'm supposed to now reflect B to give a triangle C, and the mirror line is x equals 1. X equals 1 is this line already there for us. So let's highlight that also. We're going to move perpendicularly. So perpendicularly has to go the other way. So this is the way. So move perpendicularly each point. 3 squares away, 3 squares on the other side. Keep doing for all the other 2 points. And the last point, join the 3 dots to form your image. We now have C. So as you can see, we have 2 reflections down on the same grade, one as a horizontal reflection and one as a vertical reflection. Let's look at example 3. What you realize that in doing reflection, every shape that we reflect, the image is congruent to the original one. That means the size, everything is the same. The only difference you see is that you see that the shape has been flipped. That's the only thing, but it's exactly the same as the original shape. So reflected images are always congruent to the original shape. Example 3. We have diagonal reflection. Diagonal reflection. Okay. We are supposed to reflect triangle, the green triangle in line y equals negative x. Y equals negative x. And from what we did earlier on, y equals negative x is a diagonal line. And it's this line. In this case, we're going to move perpendicularly. So it has to be a diagonal movement to make a perpendicular line, because we need to make 90 degrees. So if the diagonal, the mirror line is a diagonal line, then the flipping must also be moving in a diagonal manner to make 90 degrees, because the rule is to make perpendicular movement. So we take a point. This point is 2 diagonals and a half away. So you need to do the same on the other side. A half, 1.5, and 2.5. That's the point. Second point is 1.5 diagonal away, a half, 1.5. And the third point is 2.5 diagonal away, the same on the other side. Then you join. And one thing you need to realize is that always when you finish a reflection, you can sort of imagine flipping or sort of closing or folding the shape, and the mirror line acts as a line of symmetry or a folding line. So you should know when you get it right that the mirror line should act as a folding line or line of symmetry for the reflected and the original shape. So remember, the line of symmetry sort of becomes the mirror line when we're doing reflection. So that's a diagonal reflection. Now the next example is what we call overlapping reflection. It's where we do reflection in both ways. That's where the mirror line actually goes through the object. So we have triangle P, and we're supposed to reflect triangle P in the mirror line AB. And you realize that the line AB goes through the triangle. So which means we're going to do an overlapping reflection. What this means is that you reflect the top part of the shape downwards, and you reflect the bottom part also upwards. So we call it overlapping, the overlap. So let's go through it step by step. The rule is still the same. each point must be flipped in a perpendicular manner over the mirror line. So let's start with the top triangle. You see the top triangle, these 2 points already on the mirror line will never change, so they will still stay on the same point. They won't change because they're on the mirror line already. The only point that will change is the top bit. So these 2 points will still be the same. They can't move because they're on the mirror line. So we look at the top bit, and it's 2 squares away, so it has to be 2 squares down. So now we're going to use these 2 points and this point to form the top triangle. So I've now reflected the top down. I'm now going to reflect this bit here, which is at the bottom, also up. And that small triangle at the bottom also have a point, 2 points on the mirror line, which will not change. So the only point that changes is this point. That is 1 square away, so it has to be 1 square on the other side. So I'm going to use the flashing point, the 2 flashing points, and this point to draw the triangle at the bottom, which is going to be the reflected. Okay, so now that I've done, together mix the reflection, which is the R. So you can see that when you have overlapping reflection the same way, the mirror line acts as a line of symmetry, or like a folding point or folding line that you can sort of fold the shape and they will lie perfectly on top of each other. So far, this is what you need to know about reflection, overlapping reflection, horizontal reflection, vertical reflection. Now we're going to talk about some dynamics of reflection. Now let's describe. How do you describe reflection? Here is the case: the reflection is done for you. You're supposed to describe it. In describing reflection, you need to make 2 key points. One is the name of the transformation, which in this case is reflection. And second is the name of the mirror line. So you need 2 things: the name of the transformation, which is reflection, and the equation of the mirror line. So look at the first one. You realize that you need to identify the mirror line is going to be x equals the x-axis or y equals 0. So we say if this is y equals 0 or the same as the x-axis, then we can say that this is a reflection in the mirror line y equals 0 or the x-axis. So whichever you use is the same, y equals 0 or the x-axis. So it's a reflection in the mirror line y equals 0. The second one, you need to check carefully. Your mirror line is x equals 0.5, because the mirror line, like I said, should be like a line of symmetry. Should split into 2 equal halves. So this is called reflection in the mirror line, x equals 0.5 or x equals half. So remember 2 key things: the name of the transformation, which is reflection in this case, and the equation of the mirror line should be made mention in your answer. Okay, let's look at this one. You realize that, okay, this is definitely a diagonal reflection. What is our equation for our line? This is called y equals x. So we say this is a reflection in the mirror line, y equals x. Okay, now let's look at what happens when you reflect shapes, the coordinates. How do the coordinates change? So here, we are going to reflect triangle A in the x-axis to give us triangle B, and want to see what is happening to the coordinates. Then we'll also reflect triangle A in the y-axis to give C and also state what is happening to the coordinates. So we want to see how does the x-axis as a line of a mirror line affects the coordinates, and how does the y-axis as a mirror line also affect the coordinates. So let's start with the first one. Reflection line is x-axis or y equals 0. So let's reflect. First point. realize that negative 2 and 1 now reflect as negative 2, negative 1. If you look closely, only the y-axis changed. Only the y-axis changed. Okay, let's look at the second one. Negative 4, 1 becomes negative 4, negative 1. Also, the y-axis changed, but the x did not. The last point, also negative 2, negative 4. So negative 4 is the y-axis. It changed from 4 to negative 4. So that tells you that when you reflect in the x-axis, only the y-axis will change. When you reflect in the x-axis, the x-coordinate stays the same. The y-coordinate will change, will change sign. So you can sort of imply what will happen when you reflect in the y-axis. Let's see what will happen. So reflection in x-axis only changes the sign of the y-coordinate, like I said. Now I'm going to reflect A in the y-axis, and let's see the effect on the coordinates. Negative 2, 4 becomes 2 and 4. X is changing. Negative 2 and 1 is now 2 and 1. X coordinate has changed. Negative 4 and 1 is now 4 and 1. So also here, you can see that reflection in the y-axis causes a change in only the x-coordinate, and the y-coordinate stays the same. So that's something you need to remember. X-axis causes a change in the y-coordinate. Y-axis causes a change in the x-coordinate. Okay. Now, let's look at an exam style question. Here, two people did a reflection. So Kyle reflects triangle A in the x-axis to get triangle B. Then he reflects triangle B in a line y equals x to get triangle C. Then another person, Amy, the same triangle A, reflects it in line y equals x to get triangle D. She then reflects triangle D in the x-axis to get triangle E. And Amy says that triangle E and C should be in the same position. Okay. Now, we can't say yes, we can't say no until we go through the process that they all went through. So let's start with Kyle and see what happens. So Kyle is going to reflect in the x-axis A. So this is what happens. So we have our B now. Now B is going to be reflected in y equals x. So I'm using color to help you understand. The blue is reflected in the x-axis to get to this point B. So B is going to be reflected over the yellow line to get to C. Diagonal movement, remember. So it's 2.5 diagonal away, 2.5 diagonal. So that's 3.5. And the last one. Okay, so this is the position of C for Kyle. We're going to do the process for Amy and compare E to C. Amy start with A and reflect in line y equals x. Okay. So we finish with Kyle, and this is the position. B and C is done. So let's start with y equals x. This y equals x will reflect. This point is on a mirror line, so it doesn't change. So it stays the same. So only 2 points will change. So that is D. Now we're going to reflect D in x-axis. So this is our x-axis. Bringing it down. Okay. Now we are comparing triangle E and C. And as you can see, this is C, this is E. They are in different positions. So respect to A. So the answer is no. But you can't just say no and leave it like that. It's no, and make a reference to the positions of C and E with respect to where they started from. As you can see, no, because C is a rotation of 90 degrees anticlockwise above the origin. Because if you rotate A 90 degrees anticlockwise from the origin, you get to this point. And E is also rotation of 90 degrees clockwise from the origin to get to from A. So which means that they are both at different positions. So I've used these colors to help you understand how I got these triangles. The blue line here gave you B. The green line here gave you E. So all you need to understand is the path of Kyle is from the black to the blue and from the blue to the yellow. And the path of Amy is from the black to the pink and from pink to the green. So the answer is no. It doesn't necessarily mean that because you sort of reverse the process, you're going to have the same positions. No, it doesn't work that way. So the answer is no. So that brings us to the end of lesson on reflection. Hope you've enjoyed it. Subscribe it and share with your friends, and look forward to the next lesson on translation. Thank you.